In this tutorial, we will expand on accessing and manipulating the data in the database. We will extend the DAO pattern with direct JDBC from our previous example to use the full CRUD or create, read, insert, and delete capability for the charity object model. We will also introduce JDBC connection pooling and the JDBC transactional capabilities. And we will identify the problems of this approach and why using the Spring JDBC template is a better solution than using direct JDBC. For my YouTube students, this slideshow is part of a YouTube playlist. The playlist URL will be listed in the description and comments of this lesson. All source code for this playlist will be available for free in a GitHub repository. These are the high-level steps we will perform in this lesson. First, we will create a new Maven JDBC 8 module with the help of IntelliJ. Then we will use a beans.xml file to specify the configuration for our pooled data source and our DAO access bean. And third, we will create the JDBC transactional data access object with the interface and the implementation. And finally, we will create the main method to test the JDBC CRUD or create, read, update, and delete capability that we have coded in our data access object. So here we are back in IntelliJ. So let's have a look at our current branch. And it says we are in our JDBC 8 start branch. And now we will go over to our Markdown documentation. So we are going to update our DAO with direct JDBC for the full create, read, update, and delete capability. And we are going to introduce JDBC connection pooling from our data source. And we will expand the charity object model to include its category types. As usual, the first two steps is to create a new module, to name it using IntelliJ, to create a new package, and then we will update our pom.xml files, and we will reference JDBC2 Spring DataSource as a guide for setting up our data source and all our new POMs. So let's go ahead and do steps 1 through 3 in IntelliJ. First, we create the new Maven module. Our artifact coordinates look good. So here is the generated module from IntelliJ. So let's create a new package. And now we'll go to our POM file and we'll reference JDBC2. So we'll bring over the property values. We will bring over all the dependencies. We've got the MariaDB client. We've got all the Spring related dependencies. Load Maven changes. Now back to our Markdown document for the next step. We will create the charity model objects and its related model objects. Here we will update charity and category and its relationships in the object model. And in order to save time, this is where I will start cutting and pasting from my preparation work. So looking at our charity module object, we see it now contains the category. And the toString will output the category as well. And it also implements the equals and hash code. And now the biggest step with the most work is the charity DAO interface and charity DAO implementation class. So we're still going to use the Java JDBC, but we will expand our previous insert and find method to do full create, read, update, and delete. And as we said, we're going to add the category object to our charity. And also we will use try with resources so that Java itself will manage the opening and closing of the database resources. Back to IntelliJ. And here is our charity DAO interface. You see we've got insert, we've got update, delete, and we've got find charity by tax ID. So this is our DAO implementation, and we'll start with the insert implementation. As we see, we get the DataSource connection in a try with resources. And this is how we're going to introduce transactions. We set auto commit to false. We set up a SQL insert statement where we can pass in all the charity values to update the charity table. Then we use try with resources to create a prepared statement using the insert SQL. And here we specify that we are going to return the generated index key. In other words, looking at our database table, we are going to get back the generated charity ID from the database. And then in our prepared statement, we set all the values to pass into the SQL statement. And here is our execute update. And this execute update will return the number of rows inserted. And if it is 1, we know that the charity has been successfully inserted. So now we can get the generated charity ID back. We get the int from this column, and we set the charity ID to the returned charity ID value from the database. But at this stage, we're not finished yet because we have to also update the category of this charity and its relationship. So we have a find category for charity method that will essentially get the category value for the charity from the database. And then we will update the charity category row with the current value of the category that we have set up in our charity. And all this logic actually takes place within the transactional context. So if it's successful, we can commit, we can revert the transactional setup, and we get the charity back from our result, and we can return it. So let's have a look at our find category for charity method. We pass in the charity and the connection, and we specify that it throws a SQL exception. This is our SQL select statement. Here we also create a prepared statement to find the category in the database. And this is also a try with resources. We set the values to pass into the prepared statement. And here we execute the query. And if the results set are not empty, that means we can get the value back. Here we set up a second query where we get the actual category from the category table. So first we get the current value back from the charity category relationship table, and then we get the category value back with another prepared statement and another try with resources and another execute query. And with the second result set, we actually get the category, and we can instantiate a new category with the category ID that we got back from the database, and we return it. And here we also see that we, on any SQL exception, we will roll back any transactional updates. We will revert the connection transactional settings, and we will throw the SQL exception up the frame stack so that once we get to the main method can handle it. And here we return defined category. Let's go back to our insert. After we've found the category in the database, we will update the charity category relationship table. And here we pass in the updated charity and the category. And we see it's either going to be a completely new category, which means we have to insert a new category, or it's going to be a change to the existing category that already exists in the relationship table. So we will have to update the charity category relationship table. So let's look at insert category for charity. At this stage, we can start to understand how complex things can get when we have to update a relationship graph. And here we see basically it's just a charity and a category, but we have to implement a bunch of logic to make sure all the relationships and relationship tables will be updated, and we get back the correct object graph and the relationship between category and charity. We still maintain the same kind of pattern of using a prepared statement with resources. We set the values for the dynamic SQL prepared statement, and we do the execute update. And after the execute update, if the update was successful, we get the generated index key of our category, which is category ID, and we return the category ID value. Then we create a new category with the returned category ID value and the new category name. We set the value, and then we update the charity category relationship table. Now, before we look at this, we'll see the other option is that the category already exists, and all we have to do here is to update the charity category relationship table. And as we'll see, both of these follows pretty much the same pattern now. A SQL statement to update the relational table, a try with resources prepared statement, and returning the number of rows updated or inserted. So back to our insert statement, we find the category for the charity. We update the charity category row, which we saw can either be inserting a new row or updating an existing row. And then we update the charity category value, and we return the result back. And of course, there is a bunch of SQL exception handling where we can roll back any transaction. Now going back to our Markdown documentation. Step 6 is to create the application with a main method that runs the insert and find methods. So we're going to define our DataSource pool in the beans.xml file. We will also define our DAO class in the beans.xml file. Then we will use the Spring ClassPath XML application context to obtain the context and the Spring DataSource bean. And we'll implement the DAO in the main method. And as an example, we create a new charity, insert it, and then we find the inserted charity using the DAO. So back to IntelliJ, and we'll update our beans.xml. We see in the previous one, we only had a data source. So paste in beans, and immediately IntelliJ asks to configure the application context. And now we see a new type of data source, a MariaDB pool data source, and we see the max pool size and the pool name, which means our database connection now comes from a managed pool of resources. And then we also define our charity DAO as a bean that references the implementation class, and it uses the data source that we've defined here to get the connection. So back to our Markdown document, and in our final step, we will run our main method. And first we'll have to clear out our charity table in such a way that we do not have any foreign key relations and foreign key relationship table set up. Then we'll run the main method, and we'll run the main method from within IntelliJ. And after we've run the main method, we'll look at the database and compare it to our console output. So back to IntelliJ, and we'll bring over the main method. Let's review our main method. We get the context from the Spring ClassPath XML application context. We get the charity DAO bean from the context. And in the next steps, we create a new charity by first creating a new category called disabilities. And then we create a new charity, and we hard code all the values in here along with the category. We output our new charity, and then we run the insert on our created charity. We print out our generated charity ID. We print out our inserted category and category ID. And here we run the find charity by tax ID, where we actually get the value now back from the database where we previously inserted it. And then as a test, we change the names to /updated, and we change the category to education. We set the charity category, and then we run update on the charity that we got back from the charity in the database, and we find the updated charity and we print it out. And then finally we delete our charity that we've found, and we print out the number of deleted rows. So now we'll go to our database, and we see that the charity table is populated, so we'll clear that out. Now we've cleared out our charity table. The category table is cleared out. The charity category table is cleared out. So let's pre-populate some of those categories. And now let's look at our main method, and we'll comment out the deletion code. We'll run Maven clean install. Everything builds fine. And let's run the main method from within IntelliJ. And this looks good. We've created a new charity. We've inserted it. We got the charity ID back from the database. Then we find it using the inserted tax ID. We've added a new category, which means we successfully inserted the category, and we got the category ID back. We've also updated the charity category relationship table, and we've got the successful insert, and this is the charity that we got back from the database, and now contains the category and the category ID. Now we find the charity by the tax ID, and we see that the find by tax ID is successful. And then we update the charity with a new category, and we see we've updated the charity category relationship rows, and we have the new category of education, and we got that back. So let's confirm this in the database. We've added the disabilities in our code. We've inserted the charity in our main method. And in charity category ID, we have updated the relationship between charity and category ID, which is now category ID number 4. Now let's go back to our main method and test the delete section of the code. And in order to prevent all that SQL errors, we cannot do a double insert, so we will have to comment out the insertion code. So what we do now is we find the charity from the database, and then we call the deletion code. And it looks like it succeeded. We've got rows deleted in charity table 1. So let's confirm in our database. Our inserted charity has been deleted. Looking at category, we did not delete the disabilities category, so that is outstanding. And looking at charity category, we did delete the charity category relationship because that no longer exists. And this looks good. This means we have our first full successful create, read, update, and delete implemented using direct JDBC in our DAO, and mostly try with resources and prepared statements. And as we can see, it still requires a lot of coding effort to manage our transactions, to manage any errors, and the best way to improve on that is to use the Spring JDBC template, which provide a lot of these functionalities that we do in our code right here, and we'll look at that in our next lessons. And this concludes this tutorial. I will see you in the next lesson.